Alright, time to do a little bit of review for the Unit 5 test. So hopefully you have your homework packets ready. If you did some previous work on this, it's fantastic because now you get a chance to check your work. Couple of heads up before I go any further here. There's going to be a couple things I'm going to have you guys do for me. If there is an A and a B part to any of these problems, don't be surprised if Mr. Cook only shows you the A portion of the problem to let you do the B portion on your own. And then encourage you to go ahead and do one of two things. Either go to my webpage and click the link right here. See it? Algebra 2, 4th hour unit reviews or review solutions. Click there, you can get the answer. Great way to check your work. If that's not possible, I will have a copy that will be with Mrs. Regal, and you can check with her, and she will have the answers there for you if you want to check any of the B problems. Okay, so let's go ahead and take a look at the first problem here. Classified by the degree. Remember, degree is classified by only looking at the exponent, the highest exponent. So the highest exponent you see there is 4. Okay, and so since the highest exponent there, let me zoom in here a little bit, is 4, that means the correct answer there must be quartic. Be careful, do not confuse quartic with quadratic. I'll give you a heads up, this one will be multiple choice, and I will tell you this right now, both of those two answers will be there as a possible choice. So make sure you know the difference between quartics and quadratics, and cubics and quintics. Know the names for all of those. So once again, look at your 5-1 note sheet and look at all those first names again. You're going to need to know how to do that. Okay, so B, you're on your own with that one. Okay, let's take a look at question number 2. Consider the polynomial function. What's the end behavior on the graph? Well, one way you could do this is be able to look at the leading coefficient. See how the leading coefficient there is a positive 2, and notice the degree is an even number of 8. So without having to do a whole lot of any graphing calculator work, I would know that because the degree is even, and at the same time the leading coefficient, that 2 is positive, this must be an up and up end behavior graph. But if we did not know that, honestly, I wouldn't expect you guys to be doing that on the test. What I would fully expect all of you to be doing on this test is typing this whole function into your graphing calculator and getting a picture of it. Okay? Tough to tell by this little picture right here, so if you did this on your own, take a couple of seconds and do this on your own, because then you can actually watch it get drawn on your graphing calculator, and you'll see a couple of things. You'll see the arrows, it'll go down, it will come back up, and it will go this way. So you see those 2 arrows right there? That leads us to our correct answer of up and up. Okay? Let's move on to the next set of problems here. Let's identify whether this graph function is even or odd degrees. These are very similar to question number 2. So let's look at A. Do you notice how both the 2 arrows go up? The ends go up. So because the arrows both go up, we have an even degree function. And also because that right arrow goes up, that is a positive leading coefficient. Okay? So if both arrows go up, it's even. If both arrows go down, it's still even, right? Even, they have to go in the same direction. Odd, they go in opposite directions. Okay? Now a positive leading coefficient, it's all based on that right arrow. So if that right arrow goes up, it's a positive leading coefficient. If the right arrow goes down, it's a negative leading coefficient. So I'm going to leave B to you. Check it either online or check it with Mrs. Regal. Okay? Number 4, A, graph the function in your calculator. How about we do what they tell us to do, and let's go ahead and graph that thing. So there we go. State the number of turning points. Remember, a turning point is when the graph changes from increasing to decreasing or decreasing to increasing. So if we highlight each one of the turning points here, there's 1, 2, 3 turning points. It changed from decreasing to increasing, and then from increasing to decreasing, and then decreasing to increasing. So the correct answer that we'd have here would be 3 turning points. Okay? B, I'll leave it to you, but I'll throw you one little bone here. There's the graph of it. So write down how many turning points that thing's going to have. Okay? Don't forget, you can pause this video at any time if, any of you students want to raise your hand and say, oh, leave it, so they can write that down. Go ahead and pause that video, okay? And then move on. All right, let's look at this one right here. Determining the degree of the polynomial that generates the given data. What you have to do here is you strictly only work with the y values, okay? So just these y values right here, that's it, and you find the differences of those y values, okay? So the first thing that we are going to do is we are going to find the first differences. Now, there are two different rules of thought on this kind of a problem. One rule of thought is to generate this correct number, you ask yourself a very simple question, and that is, I just went from -16 to 1. So glancing at that number line that is up there in my classroom, if you're looking at -16 and you're going to 1, isn't that an increase, right? And that is an increase of 17. So make sure that you correctly write that increase of 17. Remember in the videos that we showed beforehand, it's very important that you put a positive sign there. You're going to want that. Trust me. Okay? That is one way to get the positive 17. The other way you can get it is you can always take the second number and subtract the previous number. Do that very carefully when negative numbers are involved, like -16. 1 minus -16 is no different than 1 plus 16, which would give you 17. Okay, so that's the other way you could have done those problems to get these differences. So to get the rest of those differences, we do the same thing. I just prefer doing it the first way I told you, which was I'm going from 1 to 4. That's an increase of 3. Okay, now I'm going from 4 to 5. That's an increase of 1. I went from 5 to 16. That's an increase of 11. Now, see how the first differences are not the same? 17, 3, 1, 11, that means that we continue. What that tells us is that this function was not a linear function. It wasn't a first degree function. So now we move on to the second differences. Okay, and now from 17 to 3. If I travel from 17 to 3, don't I decrease by an amount? How much do I decrease by? I decrease by 14. 3 to 1, I decrease by 2. 1 to 11, careful, that was an increase of 10. Don't assume that it's always going to be nothing but plus signs for a whole row or nothing but negative signs for a whole row. Sometimes that might change. But once again, we do not have the same differences, so we must continue to the third differences. Third differences, -14 to a -2. Look at that number line up there. Isn't that an increase of 12? And then number line again, if I was to go from -2 to a positive 10, that's an increase of 12 once again. Awesome. So since those third differences give us the same amount, identical amount, we are now able to say that this is indeed a third degree polynomial. Okay? Also known as a cubic function. Okay? Now this guy right here. Write the polynomial in factored form. Rule number 1, when it comes to trying to factor, the very first thing you should always look to do is GCF, greatest common factor. Zoom in here, and let's look for some greatest common factors. I can see it. The first step, identifying a greatest common factor, is look at the numbers. A 3, a 27, and a 60. Start with the low number, 3. Will 3 go into 27? Yes, it will. Will 3, if I were to count by 3s, would I hit 60? Yes, I would. So my greatest common factor, a part of it's a 3. Then, let's look at those x's. X to the third, that's x times x times x. That is x times x, and that is an x. So do I have a common factor of an x? I sure do. So my GCF is 3x. So with that GCF of 3x, that now allows me to factor out that 3x from each one of those three terms. And now I would have this here in red. Just what you see here in red makes sense. I have that red x squared because I take 3x to the third and divide it by 3x. Or another way of looking at it is distributive property in reverse. 3x times an x squared would put me at 3x to the third. 3x times 9x would put me at 27x squared, and 3x times 20 would put me at 60x. Don't think you're off the hook yet. Right there in red, can you come up with two numbers whose product is 20 and their sum is 9? I think we can. And I think we can do that. And I think we can come up with x plus 5 and x plus 4. And so our correct answer would be 3x times x plus 5 times x plus 4. That would be the final answer there for that one. Okay, so we've looked at all these problems here. I'll stop this video. So this video I will title problems 1 through 6. Okay, let's look at the next video in the playlist to help you with a couple more problems on the review.